Hello, YouTube. This is UMilzo3. In the previous lesson, we brought up the idea of a Boolean expression, and we said that not only can Java evaluate arithmetic expressions, it can tell us things like what's 72 times 12, or what's 3.6 divided by 1.1. But we can also evaluate expressions according to whether they're true or false. And we've also learned about this concept of variables, the idea that if we have information to store, sometimes it's a useful practice to store it as information into a variable so that those variables can be used multiple times in the execution of our code. Sometimes that can make things a little bit more efficient, and it can make our code a little bit less prone to errors. What we're going to do in this lesson is combine two concepts. One is Boolean expressions, which we've just learned about, this true and false kind of logic and understanding the mechanisms there, with our understanding of variables and the idea that you can store information into variables and the fact that that might be a useful and helpful thing for you to do. So we already have our Hello World class that we've been using in every lesson up through every video on this curriculum. And you can see some code here, so you might recognize if you've been following along one by one with the curriculum that this is some of my Boolean, some of the Boolean examples from the previous video. So I highly encourage you to go review those if any of the Boolean stuff is unclear, because we're just going to pick up from where we left off, and we're going to be talking about saving Boolean expressions into variables and why we would do that. So if we go ahead and say something like Boolean A equals 15 plus 26 equals 28. And then if we say System.out.println of A, we need to understand what this code is doing. So essentially what this first line does is declare and initialize a Boolean variable on the same line. So we've talked about in previous videos, I think especially in lesson 4, about especially with ints and doubles, about how you can either declare and initialize a variable on the same line, or you can do it on two separate lines. So here we basically accomplish sort of two different objectives with the first line of code. The first one says, hey Java, I want you to set aside some space in memory to keep track of a true or false statement called A. The second thing that the first line of code does is says, furthermore, I want you to basically give A an initial true or false value. And so what is the true or false value? Well, A is going to be equal to the idea that 15 plus 26 is equal to 28. Hopefully you're not taking a computer programming course if you think that that's a true statement. So obviously this Boolean is false. So Boolean A will be false. So if we say System.out.println of A, hopefully you can predict the output here. So here we would just be able to return false. And so this is an example of a Boolean variable. You could have also declared and initialized the Boolean variable on separate lines. So this is something that we really carved out in maybe a little bit too much detail in previous videos, right? But what if you have just Boolean B? So right now, B can hold a true or false statement, but it is not true or false yet. Okay, it has neither truth value. So if you haven't initialized the Boolean variable, it's not true or false. It's neither. It just has the potential to hold one or the other. So we could say something like B equals not true. And so we learned in the previous video that if we have this exclamation point, that means a negation. It means not. So B is not true. So of course this would mean that B is false. Okay. And clearly if you say System.out.println of B, what you could do is you could say, you could compile it and then you could go ahead and run it. And of course now you get your second false, right? So clearly that would be false, because not true is literally by definition false. Those are our two values, true and false. If you're not true, you're false. If you're not false, you're true. So that's kind of how this works. And then you can always change the truth value of a Boolean. So you can just completely overwrite it. You can completely overwrite it. So you could say something like, well, I don't want it to necessarily be false anymore. I want it to depend on some strings. So what if we say water.length is greater than 5, or cup.length is greater than 1. So let's think about this Boolean right here. So we're basically redefining B to be a combination of Booleans. And if you remember from the previous video, we said that these two vertical lines means or. So B is the idea that either the length of this word water is greater than 5, which is false because 5 is not bigger than 5. So that part's false. Or that the length of this cup is bigger than 1. So that has 3 letters in it. 3 is bigger than 1. So this length method, which we talked about in lesson 5, the string methods, would return 3. And so 3 is bigger than 1. So this Boolean, we have a false or true. And so if you remember, if we talk about an or statement, as long as one of the statements is true, the Boolean evaluates to true. So now if you go ahead and print the value of b, it's no longer false. It evaluates to true instead. And when we also talked about double negation, right? So for any Boolean d, if you say, System.out.println of not d, this just gives d. And here you would have a problem with this code, right? Because it says d has not been initialized. So you can't be talking about not d, right? Because it has to know what d is. But the point that I'm trying to make is that if you have not d, so 2 wrongs make a right. So if you have 2 negations, then the output of this code, if this not d were to return true, that means that d also would have returned true. If this not d would have returned false, this means that d would have also returned false. Okay, so it's called double negation, and basically 2 wrongs make a right. So if you have double negation, and it's actually no effect whatsoever. So that's sort of how we can have Boolean variables, and we can also combine them. So hopefully you're kind of clear with what's going on here, and maybe we can do a blank slate and think about some other examples. So maybe we do Boolean x equals, so maybe let's create a couple of strings. So we'll say string s1 equals Saturday, s2 equals Sunday. So this is an example of declaring and initializing 2 string objects on the same line. And we said that we can do that with variables as long as they share the same data type. And then you could say Boolean b1 and b2. So this is a declaration of 2 Boolean variables without initializing them. So there's no indication of whether they're true or false yet. In fact, they're neither. They literally are neither one. So if you say b1 equals s1.length mod 3 is equal to 0, and b2 equals b1 and not b1. So let's think about the logic here. So what we're going to do is we're going to say System.out.println of truth value of b1, and then we're going to say b1. And then this is a concatenation, right? So this is another good point to bring up. We talked a lot about in lesson 7 about really trying to get a really good and comprehensive understanding of data type conversions and implicit and explicit casting. And we said that Java prefers doubles over ints and strings over doubles. We can also say that Java prefers strings over Booleans. So what happens is that even though B1 is a Boolean, it's true or false, it's going to turn into a string. It's going to literally turn into a string, the word true or the word false, when it gets combined with this other string. So it's going to say truth value of B1 and then either true or false. But when you're seeing that true or false, it's really not going to be technically a Boolean anymore. It's going to be a Boolean that was converted to a string because you concatenated it with a string. Okay, so this is implicit casting of Boolean B1 to a string representation of it. So for example, string representation, for example, literally seeing the word true, that's a string. True would be true. But anyway, you don't have to harp on that too much. So truth value of B2 will be B2. What you have to realize is that no statement can be both true and not true. So regardless of whether you already did the computation with Saturday and you saw whether the remainder of the length of Saturday is 0 when you divide it by 3, okay? And so the answer, so that's 8 letters, so 8 divided by 3 should give a remainder of 2. So the B1 would be false, but it turns out that even if B1 were true, this Boolean, B2, is always false. So no Boolean can be true and not true, okay? So B2, it's called a contradiction, because if you say that the sky is blue and the sky is not blue, there's no way in hell that that's true. If you say that you have a dog and you do not have a dog, no way that's true. I know for a fact that you're lying. So what you would do, and then so the opposite of that, the reverse of that, is to think about what if you have an or. So you know that no statement can be true and false, but every statement could be true or false. So if you said B1 or not B1, this would be always true. Every Boolean is true or false. So I guarantee you that this one, you could say must be false, for example, just, because you could say regardless of what you make B1, and you can change B1 and see what happens to B2 and B3 here. You can try this out on your own, but B2 is always going to be false, always, and B3 is always going to be true, always, because this is, it always has to be the case for any Boolean set. So now if you go ahead and run this code, we're going to click compile, and then we're going to go ahead and run it. And we say, truth value of B1, well, it just happened to be false, right? Because we said that Saturday has 8 letters in it, right? But what if we're just going to make a very small adjustment here. Instead of saying that B1 is going to be the S1.length mod 3 is 0, what if we say S2.length mod 3 is 0? So now you have SUNDAY, Sunday has 6 letters in it. The remainder, when you divide 6 by 3, is 0. So now B1 is true, but we should still get false for B2 and true for B3. So now what we're going to do is compile the code and run it. And you can see that these are always going to be the same. The only thing that changed was the B1 variable. So hopefully it's pretty clear to you how you can store truth values and change the truth values of Boolean variables and why you would want to do something like that. And the possibilities are kind of limitless as far as how many Booleans you put together here. So you could say, you could do another example. Boolean x equals true, y equals false, z equals true. Okay, what if you say Boolean a equals x and y? What if you say x or y and z, and then you say Boolean x equals x and y or z? Or then what if you say Boolean c equals not x or not y or not z? So now what if you want to find the truth values of these, right? So with x or y, so x or y would be true, and then z would be true. So this one should be true, we expect here. And then System.out.println of b. So what about this one? X and y or z, so this one should be true. And then what about System.out.println of not x or not y or not z? So essentially, as long as one of the Booleans fails, the Boolean c should pass. And since y failed, the not y should be true. So therefore, not y or not z should be true. So therefore, c should be true. So therefore, this was kind of a bad example because all 3 of these were true, but we could do a different one. What if you say Boolean d equals x and y and z? What if you had ands on all of them, right? So then this requires all 3 of them to be true. And here x works out, but y and z does not work out because y failed. Okay, so this one would be, you say System.out.println of d, and so we expect false for this one. So we should have 3 trues followed by a false, and then we go ahead and compile and run it, and that's exactly what we have. So hopefully between these 2 videos, you've gotten more comfortable, you've gotten more familiarized with not only Boolean expressions, but also how to store them in variables, how to operate them, how to do not, and, or, how to check for equality, greater than or equal to, less than or equal to, and double negation, understanding that if you have a not of a Boolean, that's the same thing as the truth value of the Boolean itself. So you should go ahead and take some time to practice around with that. And then in the next video, we'll be talking about if and else if and else, because we can use Boolean expressions to control the execution of our program and create different console output according to who or what we're working with. So that's sort of what's happening next. So that's enough for now. So from UMills03, thanks for watching, and please subscribe.